Good evening, guys. Okay, can we start the class? Just say, put something in the chat. Yeah, good evening, good evening. So where we left the concepts at last class? De Morgan's law, right? Did anyone search for De Morgan's law? Okay, can anyone state what is the meaning of De Morgan's law in the chat? Okay, I will continue. If you are listening, means just raise the hand. Okay, it is the rule where De Morgan's law negotiate. Yeah, why it is used? You guys know, right? I just said online yesterday, right? Law helps simplify logic circuits. Yeah, logical expressions, logic circuits. Yeah. So what I'm trying to explain is that Morgan's law is used to, like, if you are using many gates in your circuits, right? While building many gates, transistor circuits, or any IC chips. If you are building that, means you need use many gates for that. So using this De Morgan's law, we convert any gate into another type of gate, like AND gate into OR gate, or OR gate into AND gate. So when the complement of logical expression is taken and the operation changes to, yeah, that's what I'm saying. So, like, using both AND gate and OR gate in a transistor, which will make the size of the transistor big and makes it, yeah, while variables complemented, yeah. Like, let me continue. I'm saying that if you both using AND gate and OR gate in a simple transistor, simple circuit, you are building an AND gate, okay, something using AND gate or OR gate. While you are using both AND gate or gate, the transistor size will become, circuit size will become bigger, and speed will also decrease due to adding another extra gate. So what this De Morgan's law do is that it will help to convert one gate into another gate, AND gate into OR gate. How? By adding resolve not to AND gate. If you add resolve not to AND gate, it will become OR gate. Vice versa. If you add resolve not gate into OR gate, it will become AND gate. Wait, I will show one good example, like how it works. Here you can see, right? Oh, here you can see, right? De Morgan, A and B of naught is equal to A naught plus B naught. Okay. So if you guys verify this, means how it will look. What I said, A dot B, not operator. You cannot write not operator like this law. This is also not operator only. You will get, this is law 1. B not. Okay, how does this work? See, think now A has 1. Okay, and B also have 1. A equals 1, comma B equals 1. Okay, now what happens? We apply these values to this first not of A and B. What will the output will be? Like if the both values are equal, both values are 1, then only the AND operation is going to work, right? Then the output of the A and B is 1. So A B will becomes 1. Then applying not for this, it will become opposite, right? 0. Now let's see prove RHS also. Now let's take RHS. What is like A is 1 right now? A naught means inverse of A is 0, right? 0. Then inverse of B is 0. So for if in OR gate, if the both the inputs are 0 means what will happen? Guys, put the answer in the chat. What will happen? For OR gate, if the both values will be 0 means OR gate equals to 0, right? So see, both LHS and RHS are proved. So by using this De Morgan's law, we can convert AND gate into OR gate into AND gate, vice versa. So what does this tells? Not of AND, not of AND gate, not of not of AND gate of input A and B becomes OR of nots. Okay, and there is another one law. What's another one law? What does it states? A A or B inverse not equals to A naught and of B naught. Just like this also same. Here we are converting and to not. Here we are converting and to not. But here we are converting or to not. So De Morgan's law helps us to like convert one gate into another gate. Okay. So which helps us to reduce the number of gates we are going to use in the circuits and increase the speed. Okay. Uh, so like we need to say why do we use this De Morgan's law, why we use in circuits? Because it simplifies logic circuits. Okay. Why do we use? It simplify circuit. Okay. And it reduce complexity. How it reduce complexity? How it reduce complexity? Can anyone in the chat? Do you know how you reduce complexity? Guys, you should be fast. Then only we can discuss many concepts in one class. Okay. Yeah. Okay. I will only tell. How it reduce? We are like here we are converting one gate to another, right? So of course we are using one less gate. and or even it may be or even it may be and. Okay, so we are using less gate. Of course it reduces the complex of the circuits. Like if you like in the place of two gates, if you are using one gate means the complexity will be reduced, right? So and also it helps to design faster chips. Means it increases the speed. Okay, next. So I'm saying, so the main goal of VLSI, the main goal of VLSI will become, when designing a chips, engineers always tries to use fewer gates, use less area, use less power, inverse speed. Okay, so when you guys are like designing a chips, what is the main purpose of your like design? To build a circuit, right? So inside that building a circuits, like if you are a good engineer, like if you are a talented engineer, then you need to like that what you are going to build is to be like, it should be faster, it should have less area, like you should keep that in mind. Okay, while you are building. So that's where the De Morgan law comes. And next, okay, for like if I need to give a good example, like why we should be building like faster chips means, I will give a good example. Okay, so imagine you are building a road. Okay, you're constructing a road where, like if you are building a road to Bangalore to Hyderabad. Okay, like if you going to build a road means, if you building a road with 100 tons and another one guy is building a road with straight road. Okay, imagine no road will be straight. I'm just saying to build a straight road. So what does that mean? Like we can travel faster and speed in the faster road, right? And it takes less time to travel, right? So what I'm trying to say is, simple path is equal to fast travel. Okay, same in circuits. Like if your signal travels from one transistor to, sorry, one gate to another gate, like one transistor to another transistor, it of course it takes time, right? So we need to maintain the circuit, like it should take less time than what the other circuits will take. Okay, so that's how you build a good chips. Okay, next topic is, so the real reason is that, for of De Morgan's law is, if you are like, oh, yesterday I said the one point, right? NAND gate is called as universal gate, NAND or NOR. Did you guys did any search on that? Why NAND gate and NOR gate is called as universal gates? Yeah, okay, I will understand. Because using NAND gate, you and or NOR gate, you can build all other extra gate, like all other gates what you have, and like AND gate, XOR gate, XNOR gate, like that, or AND gate. Using NAND, you can build all these gates. That's why it's called as a universal gates. In upcoming class, I'm going to teach like how to build that, how it works. Okay, just now keep that NAND gate or NOR gate is called as universal gate. Why it is called as universal gate? Because we can build all other gates from this NAND and NOR gate. So that's why it's called as universal gate. So I did mention that in most of the chips or most circuits, we are going to use NAND gates. Why? Because this is also one of the reason, because using NAND gate we can build any other gates. And also, so that's why using of NAND gates become more efficient in hardware. Okay, it becomes very efficient. Using NAND gate becomes very efficient. Okay, and the next topic, like we are going to like see how our first Verilog code looks like. Have you guys did research on EDA playground? I did mention. something about EDA playground, right? Just answer me, okay? Just put the comment in the chat. Guys, no answer. Huh? Okay, I will only continue with Verilog code. So, like coming to back to the concepts, the real importance is like in modern chips, a billions of I did mention about there will be around 23 to 28 billions of transistors will be present in the gate, right? In the chip, right? So in modern chips, there will be billions of gates exist, right? So even if you use one less than one gate, if you use like in billions of gate, if you make that circuit using less one gate means it will like it will gives a much more optimization than what you think. Even if you can say 1 nanosecond also means it will matter. So in VLSI means it's not only designing the hardware, like there should be also a optimization, like how much gate you are going to use and how what logic you are going to design while building the gates. Okay, so what I'm trying to say is that one transistor, that 1 nanosecond, or that one gate you are using less in a circuit will matter. It's a huge. Okay, yeah, okay. Next, I'm going to explain about like Verilog. Okay, before going to Verilog, we did discuss about combinational logic and sequential logic, right? Can you guys put in one word like what separates combinational logic and sequential logic in one word? What separates? What is the term that separates? Like what is the most important thing that sequential logic as other than combination logic? Just answer fast. Okay, I'm just asking you to answer in one word. Guys, fast guys. We can't just waste time here. Okay, no answer. Yeah. So the thing that combination logic doesn't have, then the anyway. Yeah, memory. Yeah, memory is the most important thing. Correct, correct. Memory. Sequential logic as memory, but combination logic as doesn't have memory. It relies on its current value. Like for example, like a switch. If you turn on the switch means it will turn off. Sorry, turn on. The bulb will be turned on. Or if you turn off the switch means the bulb will be turned off. Okay, but what I'm trying to say is sequential logic means it will store memory. So just a cross question, like in the first class I did mention about one word, one terminology. Okay, so what is this memory element called as? Did any of the guys think about what will be that memory element that sequential logic has? Fast, fast. Just answer me no or yes. If you guys no answer means just put it in chat. No, no, no. Yeah, it was similar. RAM or ROM. Yeah, RAM or ROM is used for memory only. But a memory element. What is that memory element I am asking? Not where that memory saves. Yeah, flip flops. Yeah, exactly. I did mention that what is flip flop in word say, I said that flip flops are the memory element which stores one bit of data. So that data is like this is the memory element which is present in sequential logic. Okay, And how does this flip-flop works? It using clock signals. If the clock signals go upward means the flip-flop it change its state from 0 to 1. For another clock going upwards, it will change its change state from 1 to 0. Okay, so like going through flip-flop means there are types of flip-flops, right? Like D flip-flop, T flip-flop, SR flip-flop, JK flip-flop. Okay, we are going to discuss like this kind of flip-flops in while writing Verilog code. Okay, I think most of you guys are from EC electronics and electrical, right? So you guys are will be familiar with the flip-flops. But what I'm going to teach you guys is now that how to write and how to understand that flip-flop in Verilog. Okay, during that time I will also explain what is the operation that is going to do in flip-flops. Just now think that there are types of flip-flops and there is one important flip-flop, okay, that is called as D flip-flop. What does it does? Do anyone knows D flip-flop? Okay, I will only answer. So what does D flip-flop flop does? What does D flip-flop does? So D flip-flop is that it stores it, it stores input data. What is storing? It stores input data when clock pulse goes upwards. Okay. What does D flip flop do? The D flip flops is like its operation is to store input data when clock pulse go upwards. Okay. Just an cross question for you guys. What happens if there is no clock pulse? Yeah, output changes only when clock pulse. Just be fast, okay? Like I'm asking you guys, what happens if there is no clock pulse inside sequential data? Yeah, if there is no clock pulse means the data is not going to change. Okay, output doesn't change. So what happens? Then the sequential logic doesn't work. Okay, then they like what is the use of then sequential logic? If doesn't stores data means it doesn't even like it requires memory, right? It will have only one memory, right? Like if the state of that flip flop is one means then the sequential logic stores one means there will be no change in the output. Then there is no required for any like changing the operation of sequential logic. So for sequential logic, clock pulse is very important. Like it is the art bit. Okay, for sequential to sequential logic works, clock pulse is needed. Okay, so where you guys use these flip flops? You know any applications? Just an example. I don't like I am also going to explain only example. I don't give like what will be the explanation for that. Okay, so the applications of D flip flop is like not only D flip flop, any other flip flop. It's like they can be used in registers, counters, RAM, CPUs. Yeah, someone did mention about RAM ROM, right? See, using flip flops you can build RAM ROM because it will help to store data. Okay, so we are did mention about something about writing our first Verilog code, right? Does anyone know how to write Verilog code? And like, what are the two forms we can write the code? Segregate that Verilog code into two concepts. Does anyone knows? Just answer yes or no. Fast, guys, fast. Should be fast. Okay, I will only explain. Like until now, we learned hardware concepts, right? Like flip flops, logic gates, combination logic, sequential logic. Okay, but now we are going to describe a hardware using language communication. Hello, turn off your mic. Yeah, okay, thank you. Yeah, until now we learned hardware concepts, right? Basic hardware concepts. Okay, now we are going to what we are going to do is by learning Verilog, we are going to describe hardware. Okay, you guys, most of you guys are familiar with some of the programming language, right? Can you guys name the languages which you are familiar with? Yeah, C, Python. What does uh, C do? C language do? C language is used to build a products, right? And what does Python is used for? Python is used for building applications, right? So like that, we in electronics we have one language that is Verilog, which is a is known as HDL. What does HDL means? HDL means hardware descriptive language. Like hardware descriptive language. What does this hardware descriptive language does? The hardware descriptive language is going to design a hardware. It's not building the hardware. It's going to design a hardware. Like how hardware should be designed. Yeah, hardware descriptive language. How hardware should be designed and how it should be simulated. Okay, so instead of writing code like other languages like in for CS students Python, we are using Verilog as a language which is used to describe an hardware. Okay, so it is used to design digital circuits. Verilog is used to design digital circuits, simulate hardware and build chips. Okay, so why Verilog is needed? Can anyone know? Answer this question. Why Verilog is needed? Guys, fast. Why Verilog is needed? Does anyone know why Verilog is needed? Yeah, to convert the language. Uh, it like it was similar to the converting language, like language converted to design. But what Sai Yoga said, right? It to design an hardware. That is exactly the point. What I needed. Okay, it's somewhat familiar to converting the language. Like very languages or like we are writing code and converting into like that into a design, and then we are going use a test bench in that to check that like simulate that circuit or design is working correctly or properly. So what does the main thing that Verilog does is it designs an hardware. Just keep that in mind, okay? If someone asks like what does the Verilog does means, don't say it is used it will build hardware. Don't say that it will build hardware. It is used to design an hardware, okay? So why do we need to design an hardware? Why can't we manually like we can in motherboard we can place like a transistor If you are doing a mini project, we can like place a transistor on a motherboard, LED bulb on a motherboard, like another every other components like on that, and we can do the project, right? So why are we going to design digitally, like using Verilog? Why? Because I did mention about that in IC chip it consists billions of transistors, right? So for that billions of transistors, we can't manually do that. So we are going to design the to prepare a design for that billions of transistors. Okay, so that's why we use Verilog. It will help to design an it helps to design an hardware. Okay, and so do you guys know how the Verilog code structure looks like? Does anyone you know how Verilog code looks like? And what are the two parts that comes under that Verilog are segregated, something like that? Okay, I will only look here. Are you guys visible? What I am writing here? Just I want to make sure that it is visible. Guys, you can see my notepad, right? Yeah, yeah. Okay. Thank you. What I was saying, basic structure of Verilog code, right? Basic structure of Verilog code, right? So how does the basic code look like? So first we are going to start with module, okay, and we are going to give that module name, okay, and inside that module you guys are going to mention like what is the like what internally what is that module using, like input output, what is taking input output, and next you guys are going to there is something called as assign operation, and next you are going to end that design, end that module using end module. Okay, this how that basic design looks like. Okay, so what does this module mean? The module means it is a keyword which is used to create an hardware block. What does that module keyword does? Like in this Verilog code, the use of module is that it will create an hardware block. Okay, what that hardware block consists? It hardware blocks consist of inputs, outputs, and what that what is the use of that module, and what does that operation that module do the operation. Okay, like it consists of like this. Okay, this is it is a simple structure of Verilog code. Now I'm going to teach you like uh, to how to write a gate, how to design a gate using Verilog code. Okay, I will teach you guys like and gate. Okay, hand gate. You guys are familiar with and gate, right? Can anyone describe what is the and gate, then what operation does in one line? Yeah, it multiplies, and like you from the symbol you can guys say that it multiplies. I just need what operation it does. If Like if a is equal to 0, then b is equal to 0, what happens? Like if in two inputs are 1, then output is 1. Yes, exactly. The AND operation works only when the both inputs are 1. Like what I said, that both now in modern days, if a family should run means both father and mother should earn, then only the family will run. Okay, then only they can. I said gave a bit example right in the during the first class. So what I am telling is, for AND gate to work, it should be 1. Both the inputs should be 1. Okay, so I did mention about something called EDA playground, right? Just after this class, just go to EDA playground, like just search for EDA playground and register. Like this will ask for registration, like using your email name and something. Just register that. You will get like this code. Okay, make sure that, see here on the left side panel, your guys seeing test bench plus design, right? Just guys, uh, put yes or no that if my like EDA playground is visible or not. I want to see the chat. Just I want need to confirm. Is that platform was visible? Okay. Thanks. Thanks. Okay. Let's continue. See, what I'm trying to say is that this is what like EDA platform playground looks like. Okay. Just when you guys have free time, I will give a task after this class. Okay. You guys should complete it. This is how our EDA playground looks like. So here, make sure you have system Verilog. Okay. Verilog or system Verilog, and also you guys here see here, you have like something called as tools and simulators, right? Here you should select iCarnus Verilog 12.0. Okay, why iCarnus Verilog means, like this is for beginners friendly. Okay, this tool is suppose for Verilog, suppose Verilog for beginners. Okay, for why this is used, this is iCarnus Verilog is used for testing that Verilog. Okay, just keep that in mind. And see here, how to design an AND gate. Okay, in Verilog language, we have two different panels. One is called as design panel, and another one is test bench panel. Okay, so in design panel, we are going to design an circuit. What happens in test bench? So test bench panel is, we are going to test the design. So what I'm trying to say is, if you guys design one gate or any other circuits, right? Before deploying or before manufacturing that gate, you guys need to test test that gate, right, to check for an error. So that time we need to run a simulation. How do you guys run a simulation? By using simulator, like test bench code. You need to write test bench code for that simulator, like every test case are working or not, like that. Okay, so I did mention about how to start our design using module, right? Module. And what are we going to design here? And gate. And gate. Okay, so what does, what are the components that are present inside the add gate? Like how many inputs and how many outputs? There are two inputs, right, inside the add gate. Input, input A, comma, input B, uh, output, there will be one output, right? Y. Y, right? And after this, These are the, like, what are the component, like what are the inputs and outputs going to that AND gate takes. You need to mention that inside the parenthesis, because that are the components that belongs to this AND gate. Okay, and you should always remember that in Verilog code, after each line you should terminate that line using semicolon. Okay, and after that you should mention what this code is doing here. Okay, what is the use of this AND gate, and what task are you are designing a AND gate. So you guys should know what this AND gate is performing. Okay, so what does that AND gate performs? It performs AND operation, right? And so that's where assign keyword comes. Assign means it's continuously stores values inside a y. Assign, y is equal to, what does this y stores? It stores AND operation of a and b. Okay, AND operation of a and b, semicolon. Next, so this is what our AND operation, AND gate does looks like, right? It consists of input A, input B, and consists output Y. And what task is going to do? It's going to perform up AND operation on input A and B and stores that value in Y. And what does this assign value do? Assign value does is it continuously store values. How? Like, for first think A is 1 and B is 0. Okay, think both are 0. Okay, then what will be the AND operation value? Y is equal to 0, right? So y stores now 0, and now you are going to change input A to 1, B to 0. Now y stores 0. So what does this y is doing here? Or this y is storing value, output of A and B input. So what does this assign is doing? Assign is helping to change that value continuously. Okay, and after that, this is what our design looks like. Okay, and after this code, you guys should uh, like this is all complete design, right, of AND gate. After you building the complete design, you should always, like, uh, finished with you are done with that code. So I am going to end that module. You guys should always give end module. Why? Because what does this module does? Did I mention something, right? This module is going to create an hardware block. And what does this end module does? It end module, like, terminates that hardware block. Okay, I have designed something hardware called as hand gate, and these are that operation. Now I am complete done with my operation, and I'm going to end that hardware. Okay, that the end module says I have completed with my design. Okay, now I'm going to, like, this is what our complete hardware design looks like. Okay, now we, after designing, what should you should guys do? You should guys do that to check that hardware. Okay, you guys need to check that hardware block, if your design is working or not, like that. You guys should always check like that. Okay, after checking that errors and after debugging the errors, you should guys move to the deployment stage. Okay, manufacturing stage. So how that test bench code look like? This is where was design code, right? And now how that test bench code looks. What does test bench code does in Verilog code? Test bench code is going to test the input cases and produce the output. If every input cases passes means, then only the design will be completed. Then only you guys can be proceed to manufacture that gate or transistor or circuits. Okay, so how does that What is the basic structure of that test bench code? Test bench code looks similar like this only. It is also create on module, and but what does it do? It have an wait for a minute. Okay, how does the test bench code looks like? How does it? It is also create going to create a module. Okay, it's going to create a module called as test bench. You guys can write test bench here also, but for keeping it short, I am writing TB. TB means test bench. After creating a module test bench, you should terminate that with a semicolon, and after this you should guys do like this: rega, comma regb wire y. Okay, can you guys guess why I have written like this? Can you guys guess any idea? Any guesses? Yeah, I will explain. Okay, yeah, reg is inputs and wire is output. uh, yeah, correct, exactly. Why reg keyword is given to in only inputs, why not outputs? Why? Because inputs we are going to change it manually, right? Like for a and b operation there will be four inputs, like a is equal to 0, b is equal to 0, a is equal to 1, b is equal to 0, b is equal to 0, uh, a is equal to 1, a is equal to 0, b is equal to 1, and both are 1. Like that we are going to change that a and b value manually, right, during testing. So we use reg keyword. What does this reg keyword does? It is like, think teacher changes question manually during exam. Okay, if you guys having like 1 year you guys having different questions, for another year you guys have another set of questions, like that. What does this reg keyword does? It has to change manually. Okay, and what does this wire do? What does this wire do? This wire is going to wire the inputs to outputs. Okay, inputs to outputs, it will wire, it acts like a wire. In how in electronics, like how that word called as wire, you guys have like it. What does in do in electronics devices? It has to travel a current from one part to another part, right? This is like that only. In Verilog code, in test bench code, this wire is going to wire inputs a and b to y. It will help to travel that a and b input to y. Okay, so what I'm trying to explain is that this is just like a wire, how it works in an electronic device, like that only. This is going to work in this code, Verilog code also. Now after this line, you should always try to import the design. How you guys import the design? You have in playground you have mentioned, right? Control. See here you have what you have done import what you have imported and gate. Okay, what is this and gate? This is and gate is called as this. See here in your design code you have designed for and gate, right? So this is and gate is imported here inside the test bench. Okay, so name always look, if you have designed any module, okay, here you have designed some hardware block. Okay, it always should its spelling should be correct. Okay, make sure that always that design spelling should be correct. If you import like if you miss any word or if, even if you change a to capital A and get where a is capital letter, then it design it doesn't match. Okay, so always make sure that inside Verilog is a code where it is case sensitive, means if you even if you like give input a as a capital and inside reg you are going to mention that small a, it will differ. Okay, then the code will doesn't work. uh, so make that point right. Note that point that Verilog is a case sensitive. So if you mentioned anywhere like something called as a and gate in all small means, it should not you should not even change that uh, this underline also. Okay, after that you have mentioned something called as UUT, right? What does this UUT mean? UUT, abbreviated form of UUT is, what does that UUT does? UUT means unit under test. Why it is called as unit under test? Unit under test means you have imported that design, right? And get you have imported and get design. Okay, so you are mentioning that this and get a you are mentioning that in Verilog code a I imported this and gate, and this and gate is what I'm testing now. Okay, UUT means I am testing this and gate with the units. Okay, what are the units? A parameter, B parameter, C parameter, Y parameter, A input, B input, Y output. Okay, so if you are like giving like means, what does this dot means? It's similar to like in your Python or C++ language only. Like your module means class, right? Creating a like hardware block. But in C or Python, we are going to name it as class. We are creating a class like that. Only in Verilog, we are going to create a module. Okay, so after importing that module, what like how are you going to import that inputs using dot operator? Dot A of A comma dot B of B dot Y of A. Like this you are going to import that design structure to your test bench code. Then after importing this test bench code, after importing this test bench code, you are going to like test the cases. That's where initial begin means initially you are beginning your, it defines like, oh, I am now beginning with my test bench cases. Okay, now don't think about this monitor. Okay, I will explain it later. Okay, now initial begin means, what does this initial begin means? It's going to like, oh, it's saying to define that, hey guys, now I am going to start my to test my test cases. Okay, so it's going to test like what happens if a is equal to 0, b is equal to 0, a is equal to 0, b is equal to 1, a is equal to 1, b is equal to 1. So these are the four test cases, right? We are used in AND gate. These are the test case we are used in AND gate, right? So what have you guys know anything about this hashtag 10? Okay, I will only explain. Hashtag like this hashtag 10 means it is called as buffer period. Okay, some the numbers which you are mentioned using hashtag is called as buffer periods. It's going to create like, if you like now think about our design is testing for first test case. What will be the first test case? A is equal to 0, b is equal to 0. So it's telling that we have testing a is equal to 0, b is equal to 0, then what will be the output? Can you guys say? If both the inputs are 0, then the output inside the AND gate it should be 0, right? So after uh, like doing the operation of one test case, this hashtag 10 means it's going to like buffer period, wait for 10 units, wait for 10 units of time. Okay, 10 units of time, not 10 seconds, 10 units. Units means very small time. Okay, it usually it will be in nanoseconds. Okay, you can't guys can't measure it. Okay, 10 units of time. Okay, after that we are going to test second case after 3 means, just for example I give here 10 seconds. You can guys give any delays. Okay, it's on depend on your, okay, your switch. And next test case, next test case, and end means you are going to, yeah, I have completed every test cases that I am going to pass. Now I am going to end the test case, and after that ending the test case, guys should end that module. Oh, this is the test bench code, test code I have created. So now I have completed my test input values. So I am ending that values. Now I am going to end that hardware block. How you guys end that hardware block? You guys should mention end module to end that hardware block. Now see, if you guys run this code means, what is it showing? Done. Yeah, the every test case is passed and it was tested, and the every test case was correct. So now it's showing done, because now your design is ready, and you guys can manufacture or send it to them for deployment. Okay, so I did leave this monitor, like said, right? There is another word, key called as uh, display, dollar display. What does this dollar display? It's going to display that input and output, and what same like that only monitor also does. Okay, how does this monitor works? It's monitor going to like monitor each and every stages of input cases. See, like, see here. Now run your code using monitor. It will show you. Yeah, see here. Monitor. What is monitor doing? It's monitoring A input, B input, and Y output. Okay, you guys know what does this percentage B means? Percentage B means you are going to print that output. Okay, you are going to print that output, but that output should be in binary. B stands for binary. So you guys are going to print that output in binary. Now run. Now run that. See, every value is in 0 1 0 1 0 1. So these are the truth table of AND gate, right? So like this is how AND gate should look like. And I did mention something about here time, right? Time is equal to percentage of 0t. 0t means you guys are initializing 0 value to time, and you are using percentage t. Percentage t means, okay, numbers. uh, okay, adding that numbers. Okay, it should be integers. Okay, now look, now run the code, and you should also mention this dollar time. Okay, dollar time. What does this dollar time does? It's going to store this time values in it. Okay, now run this code. You guys have some input as like time, right? First time started at 0. Okay, you have mentioned here, right? And percentage 0t means it will start at 0, and for 0 it ran this case and you got output. And after, you have mentioned here something called as hashtag 10, right? That is called as buffer stage. See, now time has offered buffer 10, and it's going to print output. And after that 10, it's going to print another output. After 10 units of time, it's going to print another output. Okay, this is how our test bench code looks like. Now, so for this class, this is enough. Okay, so now what I am expecting you guys to do is that tomorrow you guys should like uh, you should guys write your own code on OR gate and NAND gate. Okay. Tomorrow I'm going to like uh, ask. Okay. Have you guys done with? Yeah. That's it for this class. Okay. You guys can end the meeting. Bye.